When reviewing question number 33, a few things to keep in mind on this question. You didn't have to change your scale the way that I did here down below on the x-axis. I just thought it was a little bit easier to see. It looked really scrunched up if you did it so that each one of these was every single one. But if you did, it's still fine. What you wanted to do was graph the two functions. Remember, in order to graph functions, you need to support it with evidence, so I should see tables for both of your functions, arrows on the ends, because it told us to graph it over the domain for when x is bigger than or equal to 0. So that's why we started with solid points, ended with arrows. So that's very important. Then after you graphed, plotted your points, connected them the best that you could with the two curves, we needed to state which function has a greater value when x is equal to 20 and justify. Now, I wrote this as a sentence. You didn't have to. Whenever it says justify, it just means answer the question and back it up. So if you want to back it up with words or math evidence, it's totally up to you. But the way that I went about this question, which I think is the easiest, is by looking at your table and showing that f of 20 is 400 and g of 20 is 1,048,576. So g of x has a greater value because this is bigger than the 400. The 1 million number is bigger than the 400. With question number 34, we had to solve this inequality algebraically. So the first thing, and you need to really be careful here, because if you just make one little mistake at the beginning, it will carry with you through the whole question. You had to distribute a -3 to both the 4x and a -8, which turns into -12x plus 24. So just be careful of those signs. The next step that I did was I sorted. So I used my inverse operations, my additive property of equality, to move all of my variables. Okay, so after I sorted, then I just grouped together my like terms on both sides. That's where the -2x comes from, and that's where the -12 came from. Another thing that you want to keep in mind is after I divided both sides by that negative value, the inequality sign flips. And if you don't do this, it's going to impact how you answer the question below. Because what you're saying in this step is x is bigger than or equal to 6. So all the answers that could possibly be true in this case, your x, have to be bigger than or equal to 6. So down below here, it tells you the interval from 4 to 8. And they are talking only about integers, so only the numbers, the positive and negative numbers in that set or that interval that don't have decimals, so whole numbers. In this case, we're looking at 4, 5, 6, 7, and 8. The only ones that make this inequality true here are 6, because 6 is bigger than 6. Actually, 6 is bigger than or equal to 6, I should say. 7 is bigger than or equal to 6. And 8 is bigger than or equal to 6. The last piece here is the explanation. Explain means you have to write it out in words, so that's why you see this paragraph here. Explain everything that I did. I solved the inequality, and I got x is greater than or equal to 6, which means that x is bigger than or equal to 6. So since the only integers from 4 to 8 are 4, 5, 6, 7, and 8, we picked 6, 7, and 8 because they're the only ones that were bigger than or, that should say or, that shouldn't say nor, or equal to 6. Question 35, you needed to get r alone because it said find the radius in terms of v and h. That just means solve for r. We should even write that out. I think that's really helpful. So solve for r. So the first thing that I did, and I did all of my operations, my inverse operations, in blue. So I divided both sides by pi h, because r squared, this guy right here, he's being multiplied by pi and h. So to cancel out multiplication, I divide both sides by pi h. Since I can't really show the exact value of v divided by pi h, I just leave it as a fraction. I need to get r alone, and it's currently being squared, so that's why I took the square root of both sides. And here's my final answer over here. R is equal to the square root of this whole fraction v divided by pi h. Then down below it says determine the diameter. And this is where we have to be careful because there's no diameter in our equation yet, but we can find our radius and then just double that to get the diameter. So I just plugged in my values, got my final answer. I used my calculator for this, which you should totally do. Then I multiplied it by 2, got D is equal to 5 inches. Because here it says to round to the nearest inch, so don't lose points for rounding. That's why I'm just cutting it right off, no decimals. 5.0 means it's just 5 when I round. Number 36, you had to run a linear regression because it asks for the equation. So first you are going to add lists and spreadsheets on your calculator and then input the data. Now, if you don't read this question carefully, you would have put in the wrong numbers for the year. So if you use 2007, 2008, 2009, 2011, 2013 for your year, you didn't read carefully enough because it said when x is equal to 0, that should be used for the year 2007. So I should have used 0, 1, 2, and then since we skipped a year, that would be 4, skipped another year, that would be 6. That's why I used all of those values. Then we're going to run our linear regression model. So in the next equals line, we're going to do statistics, stat calculations, and it says linear regression. So linear regression. Let's try that again. I forgot to put in the equals line. Here we go. We want to change our values and be careful. Year is my x and attendance is my y. And what we're going to do is round all of our values to the nearest hundredth. So that's my m, so y equals mx plus b is the format that I used. You might even want to write that down to help guide you. And just make sure that you are rounding to the nearest hundredth. Keep scrolling down. Our correlation coefficient is r, and we needed to also round this to the nearest hundredth. And then it says determine whether the data is a strong or weak association. In this case, because r is very close to 1, it is a strong association. Notice how in this problem it didn't say use this to something about the context of the problem or make predictions using the context of the question. If you had to do that piece, which you didn't, but I just wanted to say a little disclaimer because I've seen it happen before, you would have had to have used the years and attendance because it would have used the word context. So you could have said, as the years increase, the attendance in millions also increases. You always wanted to talk about how the data, kind of the trend of the data based on the correlation coefficient. Since it was positive, as the x values went up, so did the attendance.